we move to the ArcGIS window, and in the ArcGIS window we can open up the regressed results. What I need to do is to right click on the cafe and ask for a refresh so I can see it, and then I got the regression results here. And as you could see, I did not bring the entire Excel document. I just click the tab and I drag and drop it, and when it's ready it occurs like a table, and I can then choose display X and Y data, and in this case we can hope that X represents X and Y represents Y. It's actually something that varies depending on what coordinate system you use and how the data was constructed, but in this case, since the data also origins from this data set, I have no doubt that this is the correct one. And the coordinate system that we are projecting it is also the same that it came from, so it's SWI-ref out and it's SWI-ref back in, which makes good sense, I would say. So we press OK, we're going to have a warning, there it is, we have no object ID. We allow for the ArcGIS to create it for us, and we press OK, and here we go. The new ones, I'm going to, just to make it sure that you could see it all, I'm going to make them green, are now the values that overlay all other kinds of values, but these, in contrast to the original one, also contains the residuals and predicted values. So now, what can we do with these kinds of things? Well, first of all, we might go right click and do properties, and then choose from a symbology to see, is there a pattern? What do we have? So if I choose the predicted values, I increase the number to 10. Let me see if I can take away the outline color, because that kind of distorts things. And since everything becomes brown when you do this, I'm going to do it up and down so I get these kinds of colors. And there's an interesting thing to note here. It predicts negative amounts of cafes per square kilometer. That's something a statistics software can do for you. In reality, it would be very, very difficult to have a negative number of cafes per square kilometer. But from an estimate point of view, that's quite possible to do. So if I press OK, this is what it generates. If I blind out all the other materials, you could see that it estimates that we're going to have a greater density of cafes towards the center of the city. We're going to have more cafes, and in some sense it makes good sense. But if we now turn to the opposite, if we look for the properties and we go for the residuals, and we do the same, we could see that the greatest anomalies, or the greatest deviations between observed and estimates, those are the blue, but they're also the negative ones, the very brown ones. The errors are located here and here. So it kind of fails to depict the number of cafes in the suburbs. It underestimates them there, and it clearly overestimates the number of cafes in the central parts of the city. Well, now, this wasn't really the reason we did the regression. It wasn't really to show that we had a good model from a scientific point of view to show anything in terms of how's the density of cafes related to parks. This is just a game where we play around to try to find out how you can construct variables directly from ArcGIS and feed them into statistical analysis. And that's what we've done. So I am sure that we could come up with a far more better set of variables that we can use to explain the variation in the location of cafes, and this is simply not the case here. It's another kind of interesting thing to note. If we're looking for the predicted values, again I return to that. Let me see, the residuals, and there we go, the predicted values. The predicted values are interesting, but they tell us very little about the organization of stuff. It doesn't tell us anything about the spatial model. This might, for all we know, be the truth. If we go instead for the residuals, the residuals tells us if there is any sort of structure, if there is any pattern to the errors. And if it's just noise, if it's minuses and plus next to each other in a seemingly chaotic way, we've got no spatial autocorrelation. And the spatial autocorrelation is very important, because as long as we've got an autocorrelation of the errors, it means that we are missing explanatory power. We've got few variables, perhaps many variables, that we would need to introduce into the model to actually make it work also from a spatial point of view. So for the future, you and others could think of what kinds of variables should be used to explain the spatial patterns of café in a major city. I'm sure you can come up with quite a few. But as long as you've got spatial autocorrelation of the error term, which we clearly have got here, because as you can see, it is a very sorted pattern that we get, we haven't got a very good model. But that's another story. So thank you.